Monica here. Welcome to the Data Podcast for Nerds, where we interview interesting individuals and ask them how they use data to solve the world's problems. Plus, we include some fun bits because we all need some nerdy data fun in our lives. Today, we have software engineer James Damgar, who is a personal friend and a fellow nerd. So, hey, James, welcome to my show. Thank you so much for being on and helping me out.
Hey, Monica. Good to see you. I love the pink. Love your
Thank
room
you.
set up there.
To start us off, how about you tell us about yourself? I like to say, what is your origin story? Like, what did you do to bring you to where you are today?
Okay, I like the parallels there as I'm a little bit of a comic book fan, so Spider-Man is number one to start off with.
I agree.
But
I completely agree.
excellent. We're on the same page.
Yes.
My name is James Damgar. I was born and raised in Tucson, Arizona, and I've known Monica and her husband Tristan for over 20 years now, so we know each other pretty well. I went to the University of Arizona, got a bachelor's degree in computer science way back in the day. I was always kind of a nerd growing up in school, like the straight A student, never ditched class, that kind of thing. Although I still knew how to get wild, in the background. I just kind of kept it low key. But I was always into computers and AI and that kind of thing. It always fascinated me. The Matrix was kind of the movie that spurred me on my path. And then after getting a degree in a bachelor's degree at U of A, 10 years later, I finally pulled together the courage to go and get my master's degree in CS at Georgia Tech. So completed that a couple of years ago. Let's see. So since then, I've been working professionally as a software engineer. Nowadays, I work at IBM, and I guess that's my origin up to today.
All right. Now, you mentioned your title of software engineer. What is your main role and responsibility within that title?
So for the most part, I've been a what's called a performance engineer. So I work a lot on analyzing the performance of systems. The application I work on is a data protection application, so data resiliency. So think, backup and restore of virtual machines, databases, containers, that kind of thing. And then in the resiliency piece, kind of protecting against malware, ransomware, that kind of stuff. A little bit of a data analysis and that kind of thing. So my main role is to make sure the system performs well, given different environmental factors, so we can actually run the product in a host of different operating systems, different physical hardware, disk storage, all that kind of stuff. So I spend most of my time looking at the performance metrics, data, that kind of thing, coming up with an analysis, recommendations, doing some coding and development to kind of improve the product. And then I work a lot with customers too. So customer problems come in. If it gets past the first line of defense of our support organization, it usually goes to development, including me. And so we usually dig a bit deeper, see if it's like a defect in the code or something we can improve on. A lot of times I got to take that information and kind of prove to the customer a point. So we have like a hypothesis and kind of go through the motions of here's the proof of what we're thinking is going on in your environment, and here's how to help. And then thirdly, I do a lot of presentations with customers. So sometimes virtually, sometimes at conferences and stuff like that. So I love that kind of thing too.
Very awesome. So you work with data analysis, and it also sounds like you do some kind of data storytelling as well.
Yeah. So in terms of what I do, I guess data, you can kind of think of it as sort of the building blocks of knowledge. So whereas think of it like atoms to molecules, right? So data
Okay.
are the atoms. They're spread all over the place, and people like us, we can kind of combine them into knowledge or the molecules or the compounds, but it takes work to do that. So you can do that kind of work in different ways. So with like a customer's data, or like if we're doing some performance testing of a product, we have to have observability of the data. First of all, we have to have some data to chew on. So we have to, build the system such that we can do monitoring. It can spit out kind of like time series data of different metrics and stuff like that. And then we can do different types of analysis on it. It might be like, statistical analysis where mean, median, standard deviation of certain data points. It might be like just looking at utilization of different system components over time and how they maybe correlate with each other, that kind of thing. And then the storytelling piece is saying, hey, I've noticed these A, B, and C bottlenecks in your environment. They seem to occur at X to Y amount of time each day. Why might that be occurring? Can we change your processes? Is it something in your environment that's limiting you, or do we actually have like a defect in the product that we have to go fix? So it's kind of coming up with, looking at it from bottom up and top down a little bit to try to come to a conclusion that really helps someone, you know, improve their process and kind of fix their issue.
You mentioned one buzzword that I think a lot of people are really excited about most recently is data observability. Can you go more into the specifics?
This kind of stuff I'm familiar with is, observing the state of the environment in which software is running on. So like, CPU utilization, memory utilization, different operating system statistics on like memory paging, disk IO latencies, all that kind of stuff. So that's pieces of data that you can capture over time. And there's different ways to observe that on a system. There's plenty of built-in tools in Linux, for example, for monitoring that kind of stuff continuously. And you can, store that to a flat file. You can send it to like a time series database like InfluxDB, Prometheus, that kind of thing. Observability in a software product, that is a buzzword. Many of your viewers probably have heard of like open telemetry, that kind of thing, and being able to basically turn on pieces of monitoring in the software, say instrument pieces of code or register that events have occurred. And then those things could be stored to a file or a time series database or, Apache Kafka, I guess, or whatever kind of receiver you want to send it to. And so observability is making sure that what's happening internally in your system can be observed so that you can kind of understand its behavior beyond what you just see on the outside. That's kind of what I think of it as.
Exactly. And without that data observability, then you have to rely more on the alerting, whether it be working correctly or not alerting too much, right?
Hmm. Yeah, so like you could have logs, for example. So there's
Mhm.
kind of your default set of logs, and they're going to output certain pieces of information, but not something that's very verbose. And then maybe there's a way to turn on tracing or elevated logging and have it spit out kind of more debug data. But still, that's maybe not sufficient to really understand the internals. So and I guess you could look at observability in both ways. It could be stuff that's kind of more customer facing, where it kind of gives you, feeds and speeds of your environment and success failure of certain operations, that kind of thing. But then there's also the internal observability that somebody who's kind of like debugging a product or maybe during the development life cycle, they'd be interested in, or support if you run into a problem. It's pieces of data that could be collected and analyzed that way. And that's maybe more, you know, internally how things are working between components, queues, and different pieces of latency and that kind of thing. So I think the more the merrier. But also I come from a performance background, so you want observability, but you don't want the observability to damage performance as well. So
That's
that's
a
kind of
really
like a
good point.
balancing act.
Exactly. Yeah. So, who do you work with primarily? Like with your data storytelling, who are you trying to tell stories to?
Well, I would say it's like really, I guess there's multiple audiences really. So say we're developing a new feature in the product and I run a series of tests and I come up with some observations and then I come up with a story. It's usually to deliver that to fellow developers to try to convince them that, we need to make some changes in certain areas of the code, or to go off and actually do those changes and then talk about them with peers. The other piece of storytelling is, someone will want to know, okay, so where are we, overall in terms of performance with these different components? And so that's usually to management or project leadership and that kind of thing, or even executives, where you kind of have to remove a lot of the technical detail and kind of just more give kind of like a summary view of things and action items, that kind of thing. And then customers are sort of the same way, and usually with them it's either, hey, we need you to change your mode of processing, or maybe there's something in your environment that's kind of a pinch point and you need to consider this, or maybe even re-architecting how you do things. And so that's a lot of times more challenging because we have to come up with proof that there is a problem. Then we also have to know the effects of certain changes and how they might, get them on their way. So it's different ways of talking to different audiences for sure.
Definitely, especially if you're talking to the more executive audience. To your point, you need to pull back the technical jargon and just high level summary, kind of get to the point, maybe put
Oh
it in
yeah.
terms of money. There's a lot of executive audiences that like to just relate things to the money and the bottom line and all of that. So just tailoring to your audience is definitely something that needs to be done.
Yeah, and it's like something I was challenged with starting out. So I come in, it's right out of university, and so I, present to management. Not only would I be like kind of nervous, or like higher level management, I'm like, oh, what do I say? And I usually would say too much, and then people would tell me afterward, yeah, you need to kind of like dumb it down for that audience or whatever. But dumbing down is not the right word, but the making it kind of meaningful to the business process, and what does it mean for the business or for the success of the product, and
Yeah.
that kind of thing. That's more
It's
what they
so
care about.
it's so hard sometimes though, because I mean, this project is your baby, right? And then you're just like so excited about it and you just want to say everything, all of the details. And so it's really hard to kind of dial that back sometimes.
Yeah, you could be like, oh, hey, I created this cool algorithm, and it's performing 20% better, and check out this graph I made about the improvement and stuff. And then
Mhm.
the manager will be like, well, what does that mean for delivery and customer experience? And I'm like, so you gotta kind of like learn how to really see what's meaningful. You
Yeah.
a lot of times you don't nowadays. You kind of think I could do this cool thing in the code, but is it really worth it from a business value point of
Mhm.
view? And that's, when you're working on software for sale, that's kind of more what you have to think about. Is the effort really worth the payback? Even if it is cool, you know, does that justify doing it?
Exactly. You talk about coding. What language do you primarily use?
Well, it's actually a mix. I've been lucky enough to be exposed to projects where I've gotten kind of like a wide range of skill exposure. So I think on my day to day, lately I've been doing a lot of Go. So Golang,
Oh.
Google's language that they came up with a few years ago. That's garbage collected, but also it comes with like a really nice development environment and a lot of helpful things like linting and an easy build process and stuff like that. So I've been working a lot in that. It also gives you a really good, solid foundation of tools to do things like performance monitoring and profiling and stuff. So it's a really nice ecosystem. But in my day to day, I'll touch and write code in like C, Java, Golang. Um, we do a little bit of like Perl scripting, old style
Okay.
stuff. And then I have some exposure to JavaScript, and then of course Python. So
Okay.
I've more Python in personal projects and in school than so far in at work. But I think that's going to probably change pretty soon because the next project I'm going to be routed in on, I think it's going to be a lot of Python based. So that'll be cool.
Okay. All right. I wore this sweater for you. This is Python. This is
Oh
Python is
yeah,
my
yeah, yeah.
animal.
So yeah, I know I love Python. Pretty much all the master's degree program stuff I did was in Python.
Was
So
it?
yeah, it's definitely one of my favorites. Um, Golang, I've come to love too. I actually want to go get one of the stuffed gophers and have that here at home. But
A gopher is their mascot?
yeah, it's gopher. I'll have to send you a
Okay.
link to it afterward. It's a cool language. I have not had exposure to Rust yet, which is like kind of the next um, latest and greatest compiled low-level language that everyone's going crazy about. I haven't had the opportunity to do anything with that yet, but maybe in the future.
I think I've heard of that. Is that just another base language, or is it specific to a certain field?
Well, it's supposed to be it's more of like a systems language, like a backend language.
Oh, okay.
It's very similar to C, but it has a lot of it's you have to do your own memory management. It's not garbage collected, but it has a lot of security features that help to avoid like the majority of exploits that you can do in C, like segmentation faults, buffer overflows, and stuff like that. It has a lot of protections against that kind of thing, and it
Okay.
has a really good ecosystem like Go. So it's growing in popularity as kind of like a C replacement at a lot of places. So really fast, high performance, non-garbage collected backend systems kind of language.
Interesting. Now you've said garbage collected, I think 3 times now. What does that mean?
So a garbage collected language. So Python's a garbage collected language. Java
Okay.
is. Golang is, and that's what that basically means is. So when you write a program, there's generally 2 types of memory that are used by your program. Memory that's on the stack, and then memory that's on the heap. And so stack memory is more static. So like when you if you have variables inside of your function or your method that are defined within there, like int x equals 5 in Java, for example, or something like that, or a equals 10 in Python. Um, those are usually stack variables. So as soon as the function is called in your program, uh, the compiler or the interpreter figures out, okay, what kind of what memory do I need for these stack variables, and it allocates them, and it keeps track of them, and it automatically cleans them up for you.
Mm.
The other kind of memory that isn't, or at least you don't really see it in things like Python or Java, is heap memory. And so the heap memory is memory that you allocate dynamically when the program runs. So maybe it doesn't know ahead of time what memory you might use. So in C, for example, you could say, hey, I want to create this this buffer of memory that's like 1 gig in size. And so I have this buffer of memory, and I have a pointer to it in C, and then I can do stuff with it. I can add stuff into it. I can do all kinds of things. Um, in Java or in Python, it's usually an object. So if you create an object of a class type, um, or like a string, a character string or something like that, those are actually usually like heap memory defined on the back end. And so what that means is they have to be eliminated. There has to be like a distinct call that says, hey, free this memory and get rid of it. Now, garbage collected languages, what they have is they have a background thread that runs periodically, or, well, not really a thread, but a procedure that is kicked off when statistics reach a certain point in memory usage or heap usage, that'll automatically in the kind of the biggest sense, it'll do a stop the world kind of thing. So your program execution will actually stop. All threads in your program stop. The garbage collector identifies all the pieces of memory on the heap that are no longer referenced anywhere. It'll mark and sweep is what they call it. So it'll say, okay, all these, it'll mark this, not used, not used, not used, not used, and then it'll come back, do another pass, and then sweep it, which is clear it out of memory, and then it'll allow your program to run again. And you'll never see that. It
Huh.
happens. It happens in the background for you. There's a lot more sophisticated ways they do it nowadays. They don't like stop the whole thing. They may stop parts of your program and stuff.
Mhm.
But that's garbage collected. Language like C or Rust, you don't get that. What you have to do is, I allocated the memory. I have to actually call a function to free it when I'm done with it. And if you don't do that, you get what's usually called a memory leak. So the memory usage of your
Oh,
program, if you monitor it on Windows or Linux or whatever, just rises until you run out of memory. And that's
okay.
kind of like the
I've
worst
seen
case.
those errors before. That makes sense. Okay.
So you're like, the reason why would you do one or the other? Garbage collected, it's really convenient. You don't have to think about it.
Mhm.
But it does have a performance penalty because that garbage collector is going to run and it's going to pause parts of your program. So if you have a really performance critical application that has to be like real time, you usually don't want that.
Okay. Interesting. Wow, it sounds like you code all day, every day. Do you have any like side projects or hobbies?
Well, so no, I usually keep it mostly to work nowadays. Although I would like to to do some coding on the side. I mean, Tristan's always wanting me to do some game programming with him and stuff, and
Oh yeah.
I've been too
Yep.
lazy. But no, so I do some stuff on the side. I guess my biggest hobby is I work with a couple of our other friends, and we run a couple sand volleyball leagues on the weekdays on Tuesday and Thursday nights. And then I do a little bit of photography stuff on the side, not too much, but occasionally, like events and other things, a little bit of modeling stuff, and um, not as much as I should be doing. And then, oh, what else? What else? I got my two fur babies, my two French bulldogs that I got to take care of, and
Yeah.
yeah, I go to Comic-Con sometimes. So sometimes,
Yes, we do often frequently go to Comic-Con. It's a blast.
yeah, yeah, and we got the Phoenix one coming up pretty soon
Oh, we
again.
do. Yes.
So we're gonna have to make that a thing.
Exactly. All right. Well, I feel the fun bits coming on. I have this new fun bits intro. All right. Fun bits, y'all. Let's dive deeper into your passion for photography and how that relates to being a software engineer.
Yeah, so like I kind of over time, over my life, I was always like wondering, I need like kind of like an artistic outlet, something that kind of uses the other side of my brain a little bit and that kind of thing. And so I kind of stumbled into photography a little bit, and part of it was like, I'd go on these trips out of town, and I have some of them hanging up in here, but taking pictures of different areas like in Europe and stuff like that. And then I kind of realized, I really like doing that, and I'm pretty good at it, sort of. Just and then I kind of like it kind of whet my appetite, so I wanted to learn more. So I went out and I really learned like a lot of the technical aspects, of course, of photography, and how to operate a camera and how to really get exposure right, and the exposure triangle. You have shutter speed, ISO, and f-stop, so your aperture, and how all those three things influence how the shot looks. And then like I learned about like flash photography and lighting, off-camera flash, and then modeling photography and getting, figuring out how to like pose models and get them to look good. And so there's all the technical aspects of it, and then there's like the creative aspect of it. So like, do I want to create a certain mood with the shot? Do I want to, have people pose in a certain way or dress a certain way or set the environment a certain way? And then a lot of that, it's like in editing, post editing, and like Photoshop and Lightroom, being able to get that look I want, elicit that emotion, that kind of thing. So it's been kind of a challenge because it's taken a lot of the stuff I'm really strong at, the technical aspect pieces, and then really kind of like stressing myself or challenging myself with the creative piece of it, and really proving that I can do it. And then I think that kind of reflects a lot on like the software engineering side, because what was originally a draw to me there was all the technical aspect of it, but also the sense of creation and being able to say, write an algorithm to do something in a certain way, and then watch it operate outside of you, right? So you write, one of the first kind of shocking things I experienced was writing an algorithm that would solve a maze, an undergrad kind of assignment they usually have, but then being able to visualize it. So I think the visual aspect of it was key for me too. So the ability to kind of figure out a technical problem and a way to solve it, and then not only that, but also see the result and see it operating and see it working. I kind of had that moment in graduate school too, when I was doing reinforcement learning, and I wrote like a reinforcement learning algorithm that trained like a little spaceship to land
Ah.
on like a little launch pad, and just watching it work and knowing, hey, I made that, it works, and I can visualize it. And I think what photography is kind of a similar way, where it's like there's a technical challenge to it all. There's a way of going about it to try to solve that, and then you kind of have the output as the shot once your editing is done and all that kind of stuff. And you're like, okay, it all came together, and there it is.
Yeah, I think seeing a final product is something that kind of makes everything more real. Is just like, I actually created this, and then you can show it to others.
Yeah, exactly. Like, here's what I did. And because like, in software and data, a lot of times it's really hard to show people.
Uh,
People ask, what do you do? and you're like, how do I even explain it to you? And they look at you, what do you do for work? And I'm like sitting in front of like a computer terminal or like a code editor, and they're just like, what? So it's really hard to show normal people what I'm doing.
Yeah, exactly. How do you like to learn new things? Like, what are your go-to resources, whether that's photography or coding or anything like that? Like, what are the resources that you usually go to learn?
Well, with photography, of course, there's searching online and that kind of thing. So how I started out is actually took there's a class. It was actually an engineer at Google that was also like a photography instructor. He like worked on some of the Google phone cameras and stuff like that. He actually taught like this kind of sort of extra credit course on Google campus, but then they made it available on YouTube, and that's how I
Oh,
kind of learned a lot of the
okay.
technical aspects of photography. But so I think it's kind of two pronged. The way I like to learn things is um, I like to learn a lot of the theory about how something works and why it works a certain way. And so a lot of times I'll go to like a textbook or like um, a series of videos on that because I really want to understand what is actually happening. But that's also kind of like separate from actually doing the thing. And, so learning all the theory of photography is separate from actually executing it in real life. And that I think you just kind of have to jump in. So I like to be a little grounded in like the theory piece of it, at least have an idea on how and why things work. But then kind of the bridging that gap in between, a lot of times the experience, I'll just kind of throw myself into it, and a lot of times fail the first few times, but at least do it. So like I think the key is don't be afraid to suck at something or to not be good at something for a while. Um, just kind of keep at it, and as long as you enjoy it and are interested in it, you'll eventually get there.
Absolutely. I think actually failing helps me learn more. And if I'm doing like a coding class or something, I'll just mess it up on purpose to read like the error code that it throws to
Hmm.
figure out how to fix it. And it helps out with understanding like the back end of how the code works. And then it also helps me in researching like how to Google certain error codes or how to Google anything. It just helps me in Googling because a lot of people still think that Googling, they're embarrassed to Google things. And it's like literally everybody Googles every day for everything.
Yeah,
Even things that you do on a frequent basis. It's like you don't have to memorize everything. Just head to Google.
yeah, it's impossible to. I mean, and well, now you can ask Chat GPT, right? But
Oh gosh, yeah.
but no, yeah, it's like, yeah, Google is kind of like an extension of your brain a little bit. I know at work I've always tried to figure out, what's a good way of doing notes and stuff like that. So like
Mm,
we have Office 365, so I use like OneNote, and I basically have this whole like categorized OneNote work workbook of, and it's basically a bunch of cheat sheets and notes and stuff
yeah.
that I just can't fit in my brain that I kind of reference back to.
Yeah. That's what I used to do a lot too, when I had OneNote. And now everyone seems to be moving to Notion. Have you heard of that? No,
No, I haven't
no.
used that yet.
Yeah. I looked at it and it just seems like another like Microsoft OneNotes. You can do all kinds of like graphs and fancy stuff, but
Okay,
yeah,
cool. Without
seems like a
having to do
cool.
the Office 365,
Exactly,
you know,
exactly. I'm not
give
sure if
Microsoft
there's like
money thing.
pricing, if it's free or anything, but yeah, another option. Awesome. I know you gave us some words of encouragement, but any other last words or recommendations that you have for the audience?
I'd say like, so if you're on a learning journey or self-improvement journey, I think kind of the key is, even if you maybe have a goal in mind, right? And it may seem like overwhelming at first, or it's too large to do, and maybe you can feel like you can't do it. Really, the key, one of the keys I found is like kind of do a little bit every day. So like every day, every week, every month, just try to chip away at all these different things. And eventually, you'll stand back a few months from now, or, a year or two from now, and be like, wow, look at all the stuff I accomplished. And it's really just a matter of, you know, doing a little bit every day. So even if it doesn't seem like a lot, kind of inch, move stuff along, an inch or a foot at a time. And you'll be surprised at what you can do.
I agree. That's a great recommendation. Where can people find you if they have more questions?
Well, I'd say my LinkedIn is probably a good way to kind of contact me from out in the ether. I also have my Instagram, like, for photography, that I'm kind of been sort of lazy at posting stuff to, but that's a good way to reach me, and hopefully be able to link to some stuff I've done there. And yeah, that's probably the two best ways.
Awesome. All right. Well, thank you so much for coming on the podcast. It was a pleasure talking about deep coding knowledge with you. Lots to share with the data community there. And for the folks that are listening, as always, happy learning.
Cool. Thank you, Monica. Thank you for having me.